In today's video, I will show you two ways to factorize a quadratic expression. Firstly, let's take a closer look to the general form of a quadratic expression. We have the x squared term preceded by the a coefficient, the term which contains the x factor preceded by b coefficient, and the c factor which doesn't have an x term. In our first case, x squared plus 7 times x plus 10 must be factorized. The coefficient a is 1, b is 7, and c is 10. All these coefficients are integer numbers, and this type of factorization is meaningful only in this case when all the coefficients are integer numbers. This first algorithm for factorizing is useful when a is 1. And let's follow the steps. As a first step, we must find two integer numbers. Whose product gives us c value. In our case, m times n is 10. And the sum of these two numbers, m plus n, give us the coefficient b of the quadratic expression. In this case, m plus n is 7. And we can observe that 2 times 5 is 10, and 2 plus 5 is 7. Therefore, the value of m will be 2 and the value of n is 5. We can write the quadratic expression in the following form. We will split the term containing x into sum of 2x plus 5x, where the coefficients 2 and 5 are m and n, calculated before, plus 10. Now we can observe that we can make a common factor in the first two terms, the x. And we have x times brackets x plus 2. And from the last two terms, we take 5 as common factor. Finally, we have the common factor, the brackets containing x plus 2 times x plus 5. And our expression is factorized into product of two sums. Let's take a second example. We have the following expression, a quadratic expression, x squared plus 11x plus 24. We say that we have the coefficient a equals to 1, coefficient b equals to 11, and coefficient c is 24. As a first step, we must find two numbers of which product will be 24 and their sum (11). Well, we know from the multiplication table that 24 can be written as 1 times 24 or 4 times 6 or 3 times 8. And 3 times 8 is quite good because the product of 3 and 8 is 24 and the sum of the two factors 3 and 8 is 11. Therefore, we will split the term containing the x factor into the sum 3x plus 8x plus 24. In the first two terms, we make x as common factor, and in the last two terms we have common factor 8, and we will have 8 times x plus 3. Now x plus 3 will be the common factor, and the result is x plus 3 times x plus 8. And our quadratic expression is factorized into a product of two sums. As we can see in this example, we have negative integers. Let's see if our algorithm will work also for this. 3 is a prime number, therefore it will be written only a product of 1 and itself. But because we have b term a negative sum, at least one of the terms m and n should be negative. It turns out that also -1 times -3 gives us the c coefficient 3. And the sum of -1 and -3 gives us the coefficient b, -4. Therefore, we will split the second term of our original expression into -x minus 3x plus 3. And we will make as common factor the x in the first two terms and -3 in the last two terms. And now our expression is factorized into x minus 1 times x minus 3. So the factorization with negative numbers also works, but we have to be careful to find the right m and n numbers, which gives us the c coefficient and the b coefficient in a proper way. And let's see our second method for factorization. In this case, a is an integer number differed from 1, and a is equal with 2. b is 5 and c is 3. We will use a slightly different algorithm for factorizing. We will multiply the a factor with c factor. 2 times 3 is 6. And we will find two other numbers of which sum is the b factor. In our case, is 5, and their factor is 6, the number we had by multiplying a and c. In our case, it's very simple because we can take m equals to 2 and n is 3. Their sum will give us the b coefficient 5. Therefore, we will split, as we did in the previous method, the second term 5x into the sum 2x plus 3x. We will make 2x the common factor in the first two terms and 3 the common factor in the last two. And our expression will be x plus 1 times 2x plus 3. Let's take a second example. First, we will identify the coefficients. A is 2, B is 7, C is 3. And we'll make the product of the first and the last coefficient, A and C. A times C will be 6. We will search for two numbers of which product is 6 and their sum is the coefficient of the x term, 7. And we can easily find them because 6 can be written 1 times 6 and the sum of 1 and 6 is 7. Therefore, m is 1 and n is 6. We will split the 7x term into x plus 6x plus 3. In the first two terms we have x common factor. We'll have x times 2x plus 1. In the last two terms we have 3 as common factor. we have 3 times 2x plus 1. Our quadratic expression can be written as 2x plus 1 times x plus 3. And finally, we will take the following expression containing negative integers. Coefficient A is 3, B is minus 11, and C is 10. The product of A and C is 30, and we will search for m and n numbers for which the product will be 30 and their sum, the B coefficient minus 11. We know that 30 is 5 times 6, but their sum must be minus 11, therefore m will be minus 5 and n minus 6. Because A is 3, we can split minus 11x into minus 6x minus 5x plus 10. I put minus 6 first to see that we can make here common factor 3 times x. In the last two terms, we can make common factor minus 5. So the first two terms have the common factor 3x, and the last two terms minus 5. So our expression will be 3x minus 5 times x minus 2. As an advice, after we splitting the middle term into a sum, we must watch carefully how do we lift a common factor so that we have two identical factors in both terms. Thank you for watching. See you next time.